So we were discussing about this Hibernate transactions, which we have already discussed. That is, in the database, transaction you can say like whenever you give the DML statement, the transaction start, and whenever you give the commit, the transaction stop. So ideally, transaction should be in effect when the application is dealing with the database and not when it is interacting with the user. Now, from JDBC and JDEE through Java Transaction API, they have provided full support for the transaction. So Hibernate acts as a client to the JDBC and JDE transactions along with the application to make use of the features while not worrying about the technical complexities. Now over here, when you want to start the transaction, you will call session.begin transaction, and when you want the transaction to be committed, you have got transaction.commit, and if in case if any failure occurs and if you want to roll back the transaction, then it is transaction.rollback. Now flushing the Hibernate session. Changes are made to the persistent objects in the sessions and they are stored in the memory. Now we already discussed how it works. Now you have got session, and this session is associated with this session factory. And this session factory is associated with the database. Now it's saying is from Hibernate, whenever it is performing the operations, it will perform the operations for the objects that is stored in the session. it will perform the operation for this object that is stored in the session. Now, then, so if you're performing any operation, you will perform on this object. When you're performing any changes, if you are making any changes, then we actually don't perform the changes on the object, on the data that is there in the database. You don't perform the operation on this directly. So whenever you're performing the operation to Hibernate, it performs the operation on the object that is stored in the session. It will make changes to this object. Now, when you call session.flush, flushing of the state occurs before the transaction, before a query is executed when an application called session.flush. So session implements transaction right behind whereby the changes are written to the database in a transparent manner and reduce the database access. So over here, once you get this, okay, all the operations you are performing over here, and finally when you call session.flush, at this point of time, it will flush all the details or it will flush all the updates to the object, to the database. Clear with this? So this happens when you call session.flush. Clear on this?
Can you just repeat that dot flush again?
Okay. Now, whenever you're performing any operations, whenever you're making any changes, Hibernate does not Hibernate does not do that operation directly on the database. It will do the operation on the objects that are stored in the session. Now, if you want to make the changes that you have done permanent to the database, then you can invoke session.flush. The job of the session.flush method is to whatever objects you are having in the database, whatever objects you have or whatever changes are made to the object in the database, that should be uploaded or that should be updated to the database. Changes made to the objects should be updated in the database. Let's say you've got a row over here in the system.
Okay.
And does it store as well if we query anything, it will flash as well from database?
1 minute. Can you please repeat?
When we'll call like a session.flash, does it contain any data from database as well? So that like a
Does it?
session.flash, it will contain whatever data we query, or it will store data from database as well.
Yes, it will make the changes. Let's say initially it was A, right? Let's say again over here you have the row over here. The content of this row initially was A. Now this operation you have updated you have performed the update operation and then from A it is changed to B. From A it is changed to B. So whenever you're making the changes, Hibernate will not directly update the database. If you see, it is making changes to the object that is there in the session. Now when you're calling session.flash, whatever objects are changed, these changes will be reflected in the database. Clear with this?
Yes.
So flushing of the state occurs when a transaction is committed or before a query is executed or when an application calls session.flush. So in these three cases, session is flushed. When you call transaction.commit, the following query is executed when an application called session.flush. So changes made to the persistent object in a session are stored in memory. Session implements transactions right behind, whereby the changes are written to the database in a transparent manner and to reduce the database access. So I hope it is clear. Flashing.
Yes.
So transaction isolation levels we have. So we know what is the locking mechanism we have in the databases. That is, when you are performing a transaction, you should get the lock on that row, and no other people or no other session should be allowed to get the lock on that row. Let's say you have got two rows in the database. Let's say you have got two rows in the database. Let's say we have got two rows in the database. This is row 1 and this we have got row 2. So if user 1 is accessing row 1, this row is locked. So if you see over here, this row is locked. Clear all this? So this row is locked for the transaction. So isolation are implemented by the database vendors and either use the locking or the multi-version. So Hibernate make use of the underlying database implementation, does not add its own semantics. So it makes use of the same locking mechanism. So most enterprise applications prefer to use optimistic locking. Optimistic locking assumes there won't be any conflicts and the data will not be updated simultaneously. Optimistic locking can be implemented by using the version number or the timestamp. And like when using a version number, a column should be added to the table and not a property in the folio class. Version name and then the column is equal to version. Whenever an object is changed, Hibernate will automatically update the version number. So when a transaction retrieves an object, its version number is also fetched. When the object is in the detached state, if the corresponding record is updated by the another transaction, then the version number in the detached state will be the older. Now let's say you have got this object. This has got version 1 and then again it's having data is A. So when you got this object, this version number is A and let's say it is initial A. When Hibernate has updated this to B, it also updates this version number to 2. Now, over here, when you call flash, this is also updated version 2. Now, after this transaction is closed. This object is detached. That is, it is no longer associated with the session. In the meantime, okay, you have got one more. In the meantime, you have got one more transaction. and this transaction has again updated the database. It has updated the database. So over here, version number 2, it has changed to 3. Now, let's say okay, from over here, version number has changed to 3 because it is updated by one more transaction. Now, Hibernate again will compare the version number of the detached object and this one. If there is a change, then this means this object is containing the stale data. The latest version number, whichever object is having the latest version number, or the highest version number will have the current data. Rest of all the objects are in the stale state, that is they have invalid data. Clear with this?
So every transaction it will create a new version number.
Yes, for every update, it should keep on updating the version number 1, 2, 3, 4.
Okay.
So, so when the object is in the detached state, if the corresponding record is updated by the another transaction, then the version number in the detached object is older. Clear with the statement?
Like a regular, like a SQL database, suppose there is a data status code, like the current one would be A, like active, and other would be deactive status. So it will do like a different version number in
Yes.
Hibernate.
Yes,
Okay.
number they are using.
Mm-hmm.
This way, version number is version, and name is version, and column is version. Special column you have. When using a version, a
Mm-hmm.
class should add to the table and map to a property in the project class. Version number. This is special thing.
Okay.
Any update issue for the detached will result in the failure since the update query will check for the current version in the table to be the same as the version number in the detached instance, which will fail with the object state exception. Now, over here you have got version 3 and you have got version 2 and then 3. Now, if you're giving any update statement on this, the Hibernate will check for the version number. So when it finds that the Hibernate number of the object is V2, whereas, and when it checks with the database, it is V3. It finds that there is a mismatch in the object number, in the version number, and it flagged this object is in the stale state. You'll come to a conclusion that this object is in the stale state and the updates will not be allowed. Updates will not be allowed. Clear with this?
Mm-hmm. Yes.
This is what we have, which was failed with an exception called object state exception. So Hibernate transaction factory class, and the transaction that you're using is JDBC transaction factory, or you can go with the JTA transaction factory. If you're going with the transactional cache, then you require this, otherwise we don't require. Clear with this? There are various implementations, JBoss Transaction Manager, WebLogic, but we are using this transaction.factory class. So if you want to disconnect the session, we can call session.disconnect. At this point, the session object is still valid and will be tracking any changes. When the application gets control back, it will reconnect to the database using the code session.reconnect. So this is just simple. If you want to connect and disconnect, so in order to connect, you can give the command session.connect. In order to disconnect, it is session.disconnect. So is it clear? And like we have been using the transactions from the beginning. See over here, session.getTransaction.begin. This is where you start, and then session.getTransaction.commit. This is where you commit the transaction, and you can call session.close to close the transaction. over here, this is what is when you are trying to store your object as a column in the database. This is what when you want to store the object as a column in the database. So over here you see in the custom mapping type, it may be desirable that the amount is always represented in the same currency, say USD, in a separate class like monetary amount, even though the database does not have support for it. So even though the database does not provide the support for the column what you want to represent. So over here you are creating your own data type. So in that case, okay, you are creating a column called monetary amount that implements the serializable. Over here you are having a constructor, and then again you are providing the set and the getter methods. And then again some XYZ methods you are providing over here. Now to implement a custom user type, your class, it should implement the user type interface. It should implement the user type interface. And then public start and final SQL underscore types. What you are using is types.numeric from this. And then return SQL types, and then again should return this. And the class what is returning is monetary amount dot class, and then again you're just comparing these two objects, the copy, mutable, null, save, get. So all this again you are implementing it. And then in the custom mapping types, over here null save set, if value is equal to null, then statement dot set null, index.types.numeric. Otherwise, monetary amount is equal to the value. You're converting the object to the specific user-defined type, and then you're getting the currency instance for the US dollar, and the statement sort set big decimal amount dot get value, and you can just map this. But this is not required. Okay, now let us quickly go through this. Now we have discussed Hibernate cache. Simple, one of the benefits of using Hibernate is ability to cache the instances. This is what, okay, this is what Hibernate is doing. So once we access the object, it is storing that object in the cache. Over here it is storing this cache. In the session it has got some memory wherein the objects that are accessed with the transaction are stored. So that memory is called as cache memory, and the use of the cache memory is whenever the session is performing the operations on the on the database, okay, directly does not hit the database, rather it performs the operation on the objects that are stored in the cache. The next, caching of data in an entity instance can provide great performance benefits. So if you see over here, if you're caching this object, if I want to make any changes, I will make changes to this object. I'll make changes to this object, v2.c. And then again, when you flash the session, at that point of time, okay, it will flash this. Otherwise, no. Let's say, okay, I'm requesting for a object. So if the object is already available in the session, it is not going to query the database. Let's say this, you have this object is already available. And when you are giving the request for the second time, now let's say for the first time it will go and hit the database and get the object from here. First time it will go and hit the database and then get the object. And the second time it is not going to do that. The second time what it is going to do is it will get the object from the session itself. Clear with this?
Yes.
So this is the advantage. If you're querying the object for the second time, it will not, if the object is not available, it will go and get the object from the database. And when the same session is querying the object, it is not going to connect to the database, rather the object is returned from the cache. So Hibernate, it provides configurable caching. where each class can be separately enabled for caching depending on its usage. So Hibernate, it provides caching at the multiple levels. That is what we are going to discuss. First level cache and then the second level cache.
So, do we need to write code like a cache and cookies earlier we did, or it will go by default?
No. You just have to enable the cache and disable the cache and the Hibernate configuration.
So that the sound is not clear.
Yeah, because 1 minute. Now
Yep.
over here you see, this is you're not going to do any, like your code will not change at all. In order to enable or disable, you can do it from the configuration file.
Oh, okay. And it will store the browser as well.
Browser results, it is no way associated with the browser. It is only associated with the database operation. Browser result cache is different. That is for browsing purpose. The cache that is being provided to the Hibernate is for the database operation. Now,
When we do a transaction, right, and until we commit, like we first select a product and it save into cart, and then we select another one, then we put address, then we put the credit card information, then finally we billing address, then finally we submit. So during this process, it will store in the flash memory or it will in the cache memory?
it will do that in the cache memory. If you're performing any database transactions on using Hibernate, then the objects will be stored in the cache.
Cache memory.
Yes, cache memory. Now, Hibernate provide caching at the multiple levels. Now let us have one on that. So we have got first level cache and the second level cache. By default, first level cache is enabled. By default, first level cache is enabled. So your first level cache will operate at the session level. Your first level cache, it operates at the session level. That is, all the objects are stored in the session. Whereas in the second level cache, you've got caching strategy, the cache provider, there are various cache providers. You can cache your queries, query cache, you have cache and process level cache, there are various types of cache. It depends which one you are using. So whichever you are using, you have to activate that. By default, first level cache is enabled and second level cache is disabled. By default, first level cache is enabled and the second level cache is disabled. So if you want to enable the second level cache, you have to enable that in the configuration file. So first level cache is the session cache which is enabled by default and you cannot disable it. And the second level cache can be chosen, like that is process cache and the clustered cache. Process cache is shared between many units of work transactions. So second level cache will work at the session function. Will work at session function. Over here, simple. Uh, let's say this is your cache, and this is the object that is stored in the cache. And this is the object that is stored in the cache. You've got a transaction. You've got two transactions. let's say. So when you're going with the second level cache, the unit of work is shared among all the transactions. All the transaction will get access to this. Whereas if you're going with the first level cache, this is your first level cache, and let's say this is your transaction 1. This is your first transaction. So in this transaction you have got this object. Now over here you will start the transaction. Let's say this is one transaction and this is the another transaction. This is one transaction and this is the another transaction. So the first level cache, the cache data is associated with the specific transaction. Only this can access. And if in case if this is trying to access, you will receive an error message. Because it belongs to this transaction. But over here, even though you are having multiple transactions, so multiple transactions can access the same cache, same object, that is this object. The unit of work is shared between the transactions in the second level cache, whereas in the first level cache, it is only by the transaction. If the second transaction is trying to access, it is blocked. It cannot access. Are you clear on this?
Yes.
So if you want the unit of work to be shared between more than one transaction, then you can go with the second level cache. If you want the unit of work to be shared by the specific transaction, then you should go with the first level cache. That is, the objects, they are stored at the session level itself. Clustered cache, it is shared between the multiple processes on the same or multiple system. So if you're working on the distributed system or distributed architecture, where the unit of work has to be shared across the geographies, then you can go with the clustered cache. So as you see in the first level cache, all the changes that are there in the persistent state, they're stored in the first level cache. Changes are made in the unit of work are cached in the first level transaction. So that is okay. If you're making any changes to this object, it is not going to directly update the database. So this is your first level cache. If an object is making any changes to this, it is cached over here itself. Let's say okay, the changes made is B, so it is not updated to the database, it is stored in the cache itself. Then changes made to the objects are written to the database only on flash. So when you're making these changes, and if you want these changes to be recorded in the database, as we have already discussed, you need to call flash method. So when you call flash method, then it will write this to the database. You can opt not to keep the data in the first level cache by using the evict. Now let's say you have queried this object and you don't want this object to be available in the session. You don't want this object to be available in the session any longer. So if you don't want the object to be available in the session, then you can call session.evict. If you don't want the object to be made available in the session, then we can invoke evict method. You can call evict method. So when you're calling the evict method, this object is removed. So object is removed from the session, you invoke evict method. This is not useful. The first level cache, it is not useful when your application is using a huge amount of data. Let's say you are issuing a select statement, you have issued a select statement and that statement is returning some thousand rows. Now, I repeat, you have issued a select statement and that statement has returned the thousand rows. So what it creates is, internally it is going to create all thousand objects and all these thousand objects will be stored over here. So all the thousand objects has to be stored over here. So this is not useful. So you have to maintain all thousand objects. So this feature is not useful because your cache has got a fixed amount of memory and will not be able to accommodate all the thousand objects. Clear with this? So you should not. This is not useful when you are when the query it retrieves some huge amount of data, huge number of rows. In that case, it is not effective. Rather than enhancing the performance, it may degrade the performance. So clear with this? The last statement.
Yes.
So and discuss the second level cache. It allows is at a higher level and allows the data to be shared across the application if opting for process cache. So this we have already discussed. Second level cache, you have got transaction 1 and then transaction 2 or process 1 or process 2. Those both will have access to the same objects. That is data that is there in the second level cache is accessible across the transactions or across the process, either on the same system or on multiple systems. The cluster cache is across multiple servers and relies on the remote communication to synchronize the cache. And second level cache stores the data in the form of values. So now, let's say
So you say second level data store the value and the form data.
nowhere it is associated with the form data. This is only associated with the transactions.
Oh.
The form data cache what we have that is different, this is different, both are different. Now let's say you're having this and if in case any changes are made then this and this will be synchronized. Now let's say again this is the server 1 and this is the server 2. This is server 1 and this is server 2. So if you're making any changes to this object, then it makes use of the remote procedure in order to synchronize these objects. Let's say okay, we have got X over here. We've got X over here. And on the some other server, from X it is changed to Y. From X it is changed to Y. So Hibernate what it does is, it will connect, okay, one session factory, it will connect to the another session factory using the remote session. And whatever changes are made, then it is going to synchronize those objects using the remote session mechanism. Clear with this?
So it will the remote session will applicable by web services or using the Hibernate.
this is provided, okay, the code is provided implicitly by the Hibernate.
Okay. So it works instead of web services?
Yes, remote is always web services. It depends like what is the logic they have implemented, but distributed database is always web services. You've got a concept called distributed database. So it has to apply the principles of distributed database transactions uh, in order to accomplish this task. We have got the principles on the database, that is distributed databases. So now when they are designing the second level cache for the distributed objects, they need to adhere to the principle of the distributed database systems.
Okay.
Now, you can enable the cache or else you can disable it. If in case if it is being set to false, you have disabled. If you want to enable, you can set it to true. Now, to enable caching, you have to provide this one. To enable caching, you have to provide a class. Like there are various cache providers. Cache providers in Hibernate. See, these are the various cache providers. JBoss, EHCache, OHCache. So these are the various cache providers. And then if you see what are the features it supports, EHCache is support caching of read-only, non-restricted read, read-write. OSCache, that is what it does not support transactional features, whereas JBoss it supports transactional features. Clear with this?
Yes. Yes.
And in this again you can use anyone based on your requirement. Most popular is the EHCache.
But EH doesn't support transactional, right?
Yes. No, we should. This is 3.3 version. So cache mode, the cache mode control how the session interacts with the second level. So you have got normal, get, put, and then refresh. So if it is normal, we'll read items from and write items to the second level cache. And if it is get, we'll read items from the second level cache. Do not write the second level cache except when updating the data. So get is you're not going to update the cache. Put will write item to the second level. Do not read the items from the second level. Refresh. Here with this.
Yes.
Now, if you want to use the query cache, then you should use hibernate.cache.useQueryCache. You need to set this to true. Clear on this?
Yes.
So you have got this from blog where blog.blopper is equal to this. So most queries do not benefit from, so by default queries are not cached. To enable the caching, call query.setCacheable of true. This allows the query to look for the existing cached results or add debts to the cache when it is executed. Clear with this?
Yes.
So for EH cache, you have this where to store the cache data. Maximum number of elements is 1000. Is the data true or false? Time to toggle the seconds 120. Time to live the seconds 120. Overflow to disk. True. That is, if the sufficient amount of memory is not available in the cache, then the contents of the cache can be moved to disk. Now over here, if you want to use the cache, if you want to cache some specific object, you can specify over here. The class cache usage, what are you doing is read and then write. Clear?
Yes.
Read-only cache you have, read and write. In read-only cache, if your application such object will be loading various classes and the classes don't and won't change during the execution of the application, you can use the read-only cache. And if you're expected the classes are going to change, then you can go with the read and write. Now, query cache, as we have seen, you should set this use underscore query cache to true, and then when you're creating this query, you're setting this to set.cacheable of true, and the name you are giving to this caching area is surveys. Clear with this?
Yes.
Now, in order to evict, that is in order controlling the second level cache. So public.evict, if you want to remove the method, then you can call evict class.class. If you want to evict a specific uh, if you want a specific object based on the ID, then you can go with this. If you want to evict the complete collection, then you can go with this. Clear with this? So it's simple.
Yeah.
If you call evict, so if you say these are the collection of objects. This is the collection of objects. So if I say evict collection, then it should delete all this. Clear with this?
Yes.
If you just say evicts object, only a specific object, this is how it works. So public void evict, it clears the object from the cache, and public void clear, it clears the entire cache. And boolean contains it in the test. So over here you have got three methods. One is evict, that will remove that specific object, and if you say clear cache, so it is going to clear the entire cache. Complete cache is cleared. And contains object. This one, it will check whether the object is there in the cache or not. Now, when to use cache and when not to use the cache. So if your database is being modified multiple times, then Hibernate won't be able to ensure that the data is valid. So some data is retrieved and not used. You're just retrieving the data, and if you're not using the data frequently, then better don't cache it. You're loading very large number of objects. If you're loading and passing millions of objects, then they not be enough memory to cache them. So the objects whatever are used frequently, you should cache them. And if a query is retrieving bulk amount of data, you should not go with the cache, because if you are going with the cache, memory will be occupied. So this is full. Over here you have this. So huge amount of data. And then again, now the system does not have the sufficient space to load more objects. So when your application retrieves huge amount of data, then second level cache should not be used. Clear with this?
Yes.
So EHS is the cache that is the most widely used one. Like when you want to work on this, you need to include this in your project.
So we have to use that two.
Hello?
We have to use the two version.
Yeah, you have to use this version.
Oh.
So once you have downloaded this, you need to add this to your libraries. I hope it is downloaded. So once you have done this, you need to include this in the libraries. So you have this EH cache. This is the complete stuff. I think it is included by default. Not required. Like when you're using this, okay, you can download this by, this is downloaded by default, the Hibernate. You need not again attach it. It is there. But if you want to import it explicitly, this is how you can. And then okay, you need to go to this Hibernate configuration file, click on source, cache properties you have, add, use minimum word. So over here, use query cache, use query cache. Value you're setting it to, sorry, we will use second level cache. Set it to true. And then hibernate.cache.provider class, and then you need to provide the name of this class. Okay, now the rest of the things, okay, we'll do it, okay, more like 4 to 5 steps are there that we'll try to complete tomorrow. We'll wind up the session for today. Okay, you'll not find any change in the application code, just with respect to performance, you'll find it change in the code. If the caching is enabled or disabled, we'll complete this tomorrow and then start with the web services.
Okay. Thank you.
Okay.